Hello again. In this video, we shall learn about how to input data into an array and output data from an array using loop structure. Remember, in the past video, we were declaring an array such as this one here, and then we would input data using sub-0, and then there would be another line here which would be cin, let's say p sub 1, something like that. But now we are not going to do that one because we are going to employ the loop facility in order to do the job. So we only have one line for input and we only have one line for output. However, this line will be traversing the array by using an index, and the index is another variable which is going to contain values which are going to change as the loop is being executed. So here you can see int p, an array of integer type, size 4 is being declared, and along with it another variable of integer type is being declared. When you come to line number 9, you find that the variable I is receiving value 0 and it is being checked. While the value in I is less than 4, I will be incremented and this particular command will be executed, cin pi, that is inputting data into an array. Similarly, the same mechanism is implemented here. The same variable I is set to 0. It is checked when it is less than 4. The loop is being executed where the output is being sought out from the array p, while I will increment to the limit which will allow it to be less than 4 in order for this particular loop to break. Let us execute this particular code and see how it works. So here we are, enter 4 integers. I enter that one and I can enter that one. So this is as far as entry is concerned. Using the loop, we are able to enter 4 integers, and using the loop, we are able to read the input from the array, the output from the array. Now, if we try and dry run and analyze the dynamic properties of this particular program, we could start by using the same physical models. Now assume that this is the memory of the computer before execution of line number 6. That this is just an array of containers which are not yet occupied. Now after int p4 and I, this scenario will change to become as follows: 1, 2, 3, 4, 5, and 6. Consider these to be balls, but then this chunk here can be isolated, and this will become 0, 1, 2, and 3, and this will be called P. Now this one will be called I, and these are now reserved. They have been put aside for, but this one remains free. So now, when we come to line number 9, for I equal to 0, I less than 4, we are assuming that now, if I is 0, it is going to have nothing, and for that matter, yet it is still our our variable, and for that matter, for now it is 0. There is nothing in I. But then when we come to C in P sub I, it means now it is 0, there is nothing. And if we are going to input anything in sub I, it means it is C in P sub 0. So at P sub 0, this is P sub 0, the scenario would change and look as follows. Consider this to be the same RAM. This is the same RAM, and these are just some balls. So this is the array P. This is P. This is P, and this is sub 0. This is sub 1. This is sub 2. This is sub 3. Now, since there is nothing in I, then we consider it to be P sub 0. So at P sub 0, we enter 2. Let us put 2 pebbles in there. Then I will have to be incremented to 1 pebble. So when it comes to C in P sub I, then there is 1 pebble inside this ball here, and for that matter, the computer is going to point to P sub 1. So I can enter, let's say, 3 pebbles here, and then I will increment to 2. That is 1 plus 1, and then we have 2 objects in I. So the loop is not going to break because in I there is an amount which is less than 4. There is only 2. So this particular line is going to repeat C in P sub I. So since in I there is now 2, it means the computer is going to point here, and if we enter, let's say, 2, then in P sub 2 there is 2. Now I is going to increment by 1, so here I is going to have another pebble having 3 objects. Now 3 is still less than 4, and for that matter this line of input is going to be executed, C in P sub I. But in I there is 3, and for that matter it is pointing here, and if I enter, let's say, 1, then 1 will be stored in P sub 3. Then I is going to increment by 1, and it's going to have 4 quantities. And since 4 is not less than 4, it means this condition now will cease to satisfy, and for that matter, the computer, this loop is going to break, and it is going to jump into the another set of lines. And now the condition, the line number 15, will reset the value of I from 4 to 0. And for that matter, what's going to happen? This particular variable is going now to start from empty point of view. And again, now it is 0. And when the computer comes here, see out Pi, it means it's going to point at P sub 0. It means there is nothing yet, it's 0, and it's going to point at P sub 0. So we will see 2. We will see number 2 on the screen, because 1, 2 will be counted, and then we are going to see 2 on the screen. But then I is going to increment it 1. 1 pebble is in the dish I, and the C out, this line is going to be executed. C out Pi. So I has got 1. P sub 1 is this one. So we are going to see 3. And then I is going to increment it to 1. That is another pebble is increasing. And when we see here, we get C out P sub I, then that is P sub 2, and then we are pointing here, So from here we are going to see 2 again displayed on the screen. Then I is going to increment to 3, and since 3 is less than 4, this line is going to execute C out P sub I. Then that is P sub 3, and we are going to see 1, which is the counting of the pebble, which is in array P sub 3. So this is what we see on the screen. But again, I will increment it to 4, and since 4 is not less than 4, 4 is equal to 4, then the loop will break and this program will come to an end. So more or less, this is what we see on the screen. However, let us change these RAM diagrams, these physical models, into what we call the hand-drawn RAM diagrams. If we abandon this one and we bring about a new blackboard, let us use another kind of drawing to interpret the same program. If we come here and we say before the declaration, that is before line number 6, before int pi, this is the computer memory. It is an array of empty rooms. This is before line number 6. Now after line number 6, that is after int pi, let us see after int pi, this is what happens. 1, 2, 3, 4, 5, 6. So a chunk of memory of size 4, that is 0, 1, 2, and 3 of 4 will be spared, and it is going to be labeled as P. And then another part of memory called I is going to be reserved. So this is the chunk of memory that we are getting due to these particular 2 lines. One is P and another is I. Now, when the computer comes at this line here, for I equal to 0 and I less than 4, this is what happens. This is the memory, that is RAM. This is the RAM of the computer. So we have got 0, 1, 2, 3, and this is P. This is P. That is P. And then we have, this is I. All of them were reserved. But then, if this is the situation, this will remain reserved. This is reserved. This is reserved. And this is 0. Now, I equal to 0. From this particular situation, I equal to 0. Then when we encounter C in P sub I, this is the particular area that is being pointed to, and the RAM will change to the following situation. Here, the same RAM is going to change. Here, we have 0, 1, 2, 3, this is P, and this is I. Now I is 0, so P sub 0 is here. If we enter 2, 2 will come there. But I is going to increment to 1, so I will change from 0, it will acquire the value of 1. This is 1. So C in P sub 1, this is pointing here. If we enter 4, the 4 will be written there. Then I will be equal to I plus 1, so I will change from 1 to 2. And then C in P now sub 2. So P sub 2 is here. If we enter 2, 2 will be entered there. And I will change from 2, it will be now 3. So I will be 3. And then we have C in P sub 3. Sorry, if we have C in P sub 3, it means it's going to point here. Sorry. So if I enter 6, 6 will be there. Now again, when we come to this line number, for this matter, after this particular execution, then I is going to increment from 3, it will become 4. From 3, I is going to become 4. Now, since I is 4, the loop is going to break. It means this part of program is going to break, and this portion now will come into play. Let us assume now we are looking at this line. For I equal to 0, I less than 4, I plus plus. What's going to happen is that I is going to be reset. I is going to be reset to 0. So I will be 0. Now once I is 0, you come here again that when we are saying C in P sub I, then it means P sub 0. At P sub 0, C out. Now it is C out. C out. C out P sub 0. At P sub 0, we shall see 2. And then I will increment from 0 is going to be 1. I will change it to 1. Now, it means here now we are going to have C out P sub 1 instead of sub 0. At sub 1, we have 4. So 4 will be outputted. Then I is going to change from 1 to 2. This one is going to change to 2. And this one will be changing to 2. C out P sub 2. Then at P sub 2 we have 2. So 2 will be displayed on the screen. Again, I is going to increment from 2 to 3. Now, it means here it will be C out P sub 3. At P sub 3, we are having 6. This one here, P sub 3. So, after that, I will increment from 3 to 4. And once I becomes 4, this particular loop here is going to break and the program will come to an end. But on the screen, we are going to see these particular integers. Now, this is as far as visualization of this program using physical models and RAM diagrams is concerned. And as you can remember, this is a code about arrays, but then we are using loops to control the way we enter data into the array and the way we read data from those particular arrays. With that one, I have to thank you and say bye.